Hi, my name is Gabby, and we're going to talk about Gibbs Free Energy. So what exactly is Gibbs Free Energy? Gibbs Free Energy, or G for short, is an important topic in thermodynamics. Thermodynamics is a branch of physics and chemistry that explains how heat and temperature are related to work. In order to understand Gibbs Free Energy, you need to understand two of the four laws of thermodynamics. The first law is conservation of energy. That is, that when energy passes into or out of a system, the system's internal energy changes equally. So, when you light a candle, the energy that is stored in the wax that is being burned is the same as the energy released by the light and the heat of the flame when it burns. The second law is that entropy, which you can think of as disorder, in the whole universe will always increase. It's like when you try and organize a bookshelf. Even though you end up organizing the bookshelf at the end of your task, the rest of your room is still a mess and is probably messier to accommodate for the more organized shelf. So, if the second law states that the universe becomes disordered, then how does anything happen? This is what Gibbs Free Energy explains. Basically, the reason why there can be life and order is because making bonds releases energy. It is exothermic, and therefore it decreases the internal heat in the system, also known as enthalpy. Gibbs free energy is simply the formal relation of temperature and these two variables, of heat content, also known as enthalpy, and disorder, also known as entropy, to tell us when a reaction will occur. The equation is Gibbs free energy equals enthalpy minus the product of temperature and entropy. If G is negative, then the reaction will occur. So, when a reaction releases energy, that means that the heat content of the system is lowered and that the enthalpy is negative. This means that even though making bonds can make a particular system more ordered in certain reactions, since the formation of bonds releases energy, or heat, the reactions that happen are the ones that make the universe more disordered as a whole. In the equation, that means that when heat is released in a reaction, the enthalpy is negative, thereby contributing to the spontaneity of the reaction by driving G down. On the other hand, entropy contributes to the spontaneity of a reaction only when it is positive, meaning that the reaction makes the system more disordered. So, for the system to become more ordered through a spontaneous reaction, the reaction has to have a more negative enthalpy than the product of the temperatures and the entropy.